Hi, my name is Ian Tracy, and I'm here to talk today about Erlang, the future of the web, with concurrency specifically. What exactly does that mean? Concurrency means being able to run processes simultaneously, not necessarily from a parallel computing approach that you traditionally see in distributed systems, but from an approach where you can have nonstop code running that's fault tolerant, can take updates on the fly, and also can be distributed within a system or a platform. This concurrency philosophy is really exciting for the web when you're trying to deal with a massive amounts of traffic as well as the scalable infrastructure that you'll need to build a modern day web. When you have exponential growth across almost every platform, we've had more people on the web than we've ever had, and the people that are on the web are demanding more of it than ever before. And concurrency can really help us deal with a lot of those issues of trying to kind of make a method to the madness, as well as make sure that the continuous deployment philosophy that is really becoming into mainstream practice of web development stays in practice. Erlang was created in 1986, almost 29 years ago, by the company Ericsson, who's really a leader in sort of the telecommunications industry with telephone switches and the infrastructure that goes into telephone lines. And they used Erlang as a way to switch between the gates of telephone lines and to maintain all of that traffic and update the code in real time without having to sacrifice taking down phone connections. And so Erlang, adapted on the web with concurrency, can do something really similar. So let's take a little example here and go check out concurrency in Erlang. So here we have a good example that really sort of emulates a lot of what's going on with Erlang when it is running concurrency. So if I boot up the Erlang shell here and load the example that we have, and that's just a small error that we're getting, just a warning for that. So before I start this, if you take a look at the code here, you can see that we obviously have this method start that's then being pumped into say something. Say something takes a what predicate, which then adapts it to a certain amount of times that the statement's replicated. And from first glance, similar to any sort of procedural programming paradigm, your gut instinct would be this method is going to say hello 3 times and goodbye 3 times. And that's no different than something you'd experience in Java or Ruby or C, where each statement is sort of executed at once. And in this case, each function is executed once. But you'd be a little bit surprised after first glance once you kind of dive into how concurrency in Erlang works with spawning and spawning the different methods and predicates around that. And so let's just start this and you can see what I mean. Let's zoom that in there a little bit. So right away we can see that our initial assumption was wrong. We do not see hello 3 times and goodbye 3 times. What we end up seeing is hello, goodbye, hello, goodbye, hello, goodbye. This is just a process ID, which is Erlang's way of maintaining which process is running. And you can see that in fact we do not have the procedural sort of iterative approach to these method calls that we originally were anticipating. And this is a really powerful tool when you want to run things concurrently and pass things back and forth, as well as sort of these live code updates that Erlang is really famous for, called hot swapping, where you can transfer in and out of code really quickly because one of your processes are actually running individually from the other one rather than them both being reliant on each other. So this is a really exciting feature of Erlang that a lot of developers are now sort of getting behind in terms of trying to apply it to a web standpoint where you're dealing with multiple different user bases from across the world and different demands, as well as trying to update code and switch out code with sort of an always up mentality that the web has. Now we can look at sort of a little bit more of an advanced example that I think directly applies a lot of the functionality right out of the box of Erlang to something like a messaging system. So here we have a simple example called ex2. It has 3 basically, or I guess you could really boil it down to 2 main functions, ping and pong. And these 2 functions are going to display an output and send that output to another function. And going off of what we previously had talked about with spawning and the fact that they aren't concurrent, the behavior of this application is going to be similar to what you would expect given what you saw in EX1. where the applications are, since they're running concurrently, you can pass messages to them back and forth despite the fact that they're being called succinctly in a specific order. So let's show this in action. So let's boot up the Erlang shell. Let's load ex2. You can see ex2 loaded. And let's do ex2 start. And so interestingly, and not necessarily surprisingly, you can show here that it received both of those messages. Once again, this is the process ID identifying which process this is running off of. And down here, it's pinging and ponging back and forth, given what we've written here. And then at the end, it finishes them succinctly in actually the opposite order that it started in. So if we go over here and we identify the code, you can see that right here, we've spawned Pong initially, and then we've taken that same instance, we've instantiated ping, and given it the Pong ID, which we've set up here in this spawn. And so what that's doing when you trace back into the code is what it's doing is it's allowing us to send it to ping, or to Pong, I'm sorry, given this function, this method call here. It's then displaying ping receive Pong. Then this n-1 is simply keeping track of a counter that allows us to do this X number of times. So that's a minor detail. It's then receiving that and saying Pong received ping. And if it's quote unquote the flag is finished, then it would stop the execution. But it's interesting when you sort of break down this code and you look at how these spawnings work and how you can actually apply process IDs and other IDs into spawns in order to make them more dynamic, you really begin to see a lot of the applicability to something like a messaging system, where you could very easily pass in either a user ID or a conversation ID to the same spawning, and you could create a concurrent application that's running code basically in two environments, or have one environment that has two instances of something running at the same time. And so in this example, it's really easy to tell that Erlang makes this extremely easy. I mean, here we have out-of-the-box concurrent environment and basically 29 lines of code. And a lot of those are boilerplates of trying to make this efficient and not completely eat my CPU by running infinitely, as well as the fact of a boilerplate of loading the module and the export and things like that. So it's actually less than 29 lines of code. You can write applications that are concurrent and pass messages back and forth to different instantiations of functions. And so that's a really powerful tool when you're thinking about wanting to build a massively scalable online platform that can handle a lot of functions at one time. And innately, this is somewhat of what a server is already doing, of trying to handle communication channels all at once. And so I think the conversations really become in the developer community of, if we have similar conversation channels in telecommunications to the web, where you're handling a lot of traffic, your expectations are is that it will always be up and fault tolerant, and even on the web, the behavior and processes are infinitely more complicated than something just like voice. Why aren't we handling it the same way that the traditional telecommunications industry did? And that's sort of become, I think, a trend you've seen with things like continuous deployment, where you continuously deploy an application and update it, as well as things like Scala being used in a lot of popular startups to help fix the problem of running scalable code in different environments and instantiations.